All right, friends, welcome back. We're talking about 9.3 special cases when multiplying polynomials. That's 9.3 in the red Lawson book with the kayaker on the front of it. It could be for other curriculum as well. The two things that I want you to take away, I know I always tell you, like, get out your notebook and write down these notes that I'm telling you, and I know like half of you don't, but I do need you to write these ones down because these are super important. Difference of squares, perfect square trinomial, these are our formulas. Now, these formulas look kind of complicated, so we're going to go through some examples so that you understand them. So let's talk about how this works. What we're going to do here is, for our first one, we're going to talk about difference of squares. So pause the video and write those formulas down. Difference of squares is what we're going to talk about first. Also, I want you to pause the video, and if you don't already, have a cheat sheet of perfect squares, perfect cubes, your 2s, your 3s, your 4s, your 5s. So pause the video, write those all down so that you have them. These are what I like to call friendly numbers. So these friendly numbers will come in handy because then you know your perfect squares. Difference of squares. The way to recognize it, well, first of all, the word difference means subtract. So you'll notice all of these are subtraction. That's because difference means subtract, and it does not work if we have an addition sign in there. All of these are perfect squares. So the reason I want you to memorize the perfect squares is so that you can recognize when you have a binomial, remember a 2, so a 2-parter here, that if you see a perfect square, then you're like, hey, wait, that might be difference of squares. I want you to be able to recognize these straight away, especially my Algebra 2 kids. My goodness, you use this all the time. So what we're going to do here is, you'll see that we have x squared minus 9. Reading is new today. I don't know why. What that really is x squared minus 3 squared, right? Which means this guy factors down to x plus 3, x minus 3. That's because if we were to FOIL or distribute or box method this right here, we would end up with x squared minus 9. You can pause the video, go ahead and FOIL or box method that. You should end up with x squared minus 9. Same thing over here. You'll notice that we know x squared minus 121 is really x squared minus 11 squared, which means that this guy factors down to x plus 11, x minus 11. Bam, done. There's your answer. You factored that. Right here, this one's a little bit trickier, and so it does help to write underneath it what you're squaring. So like this guy is 2x squared minus 5 squared. Because remember, when it's written like this in the parentheses, the 2x squared, I'm sorry, I don't mean to write so small. I need bigger paper. But the 2x, the squared distributes to both the 2 and to the x, so it would be 4x squared. So we have 2x squared minus 5x squared, or minus 5 squared. So that gives us 2x plus 5, 2x times 2x minus 5. I did a terrible job writing that. Let me rewrite that. So that's 2x plus 5, 2x minus 5. Okay, sometimes you're going to see a 2-parter here and you're like, that looks like difference of squares, but you know your perfect squares and you're like, 18 is not a perfect square. So something's funky here. What you always want to do first is, can I make my life easier? And when I say that, what I'm saying is, look at your chunks. We got 2 chunks here. Is there something in common that we can take out of them? And in this case, they're both even numbers, so we can definitely take a 2 out of them. So if we take a 2 out, we end up with 9x squared minus 16. Okay, so now at this point, that is a perfect square minus a perfect square. And if it helps again, you'll write 9x squared is really 3x squared minus 4 squared. Now, don't forget to bring down that 2. I always forget that part. So you're going to say this whole thing factors down to be 2, and then it's 3x plus 4, 3x minus 4, and that would be your factored form of this. All right, let's move on. We're going to talk about perfect square trinomials here. Perfect square trinomials, they look like this. A perfect square trinomial is a binomial, a 2-parter here, that has a squared up in the corner there. Now, if you come to me and you say, oh, this must be x squared plus 16, I'm going to be like, I don't even know what I'm going to do, because no, you can't just distribute that squared to here and to here. At the very least, you have to do this. X plus 4, and because it's to the squared, you have to do it twice, right? So x plus 4 times x plus 4, and then FOIL or distribute or box method that. But folks, if you have not yet learned this, I'm the laziest person ever. I'm going to teach you the easiest way to do things. You could FOIL it all the way out every time, but instead there's a pattern, and it's super important that you actually learn this pattern because it will help you when we get into factoring later in this chapter. Here's how the pattern works. You take this guy in the front and you square it. So we say x squared. Then you multiply these two things together. X times 4 is 4x. And so then you double that. So 4x doubled is positive 8x. And then you take that last thing and square it. So plus 16. And you have just multiplied this out, foiled it, distributed, box method, whatever. You have just done that without actually having to do it. So let's try that again. So for this guy right here, this next one, x minus 7 squared, quantity x minus 7 squared. Again, you don't just distribute that squared to here and to here. It doesn't work like that. What we do is we say, okay, take that first one, we square it. Then we multiply these two things together. X times negative 7 is negative 7x. Double it, we get negative 14x. Then we take this last one, negative 7, and we square it. Here's a friendly reminder. Remember, if you have negative 3 squared, that's negative 3 times negative 3, which is positive 9. If you have negative 3 squared like this, that is actually negative 9. So you got to be really careful with your negatives. Why is that relevant? Because right here, it's negative 7 times negative 7, negative 7 squared. So that's positive 49. What I'm getting at is when you're doing these perfect square trinomials, that last guy is always going to be positive, okay? The first guy is going to match whatever's in here. So let's try another one. This one right here. Okay, so this one's a little tricky because we got a number in the front now. All we do is we square that front chunk. So that's going to be 4x squared. Then we multiply those two things. So 2x times 3 gives us 6x. Double it, we get 12x. Positive 12x. And then we square that last one, which is positive 9. Bam! You have just multiplied that out without having to FOIL or box method. All right, this one again is a minus, so you got to be cautious of this. We take this first one and we square it. So we get 16x squared. Then we multiply these two together. At 4x times negative 1 is negative 4x. Double it, you get negative 8x. Now, we take quantity negative 1 squared, which is going to give us positive 1, and you have just FOILed that out. So that is the fast way to do those. Learn that method. I promise it will pay off in the end. If it doesn't pay off now, it will pay off in Algebra 2. Hope you found that helpful. Let me know if you have any questions at all.